So, hello everyone, and good evening, and welcome to this episode 2 that we are conducting of our online series. So, we had planned to conduct 2 episodes every month, but last month we could do only one. But we will make up uh, for it this month, and we will have our 2 scheduled episodes this month. So, welcome once again, and I hope my voice is properly audible to all of you. Is my voice loud and clear? Yes. So I hope it's all okay. And it is the monthly, as I told you in this online series, what is going to happen that we are going to discuss and share ideas, experiences, and problems. So it's an online platform for the civil structural engineers. So last month when we conducted our first episode, it was a very good experience for us also, and learning from it, we are here with the episode number 2. So because this is our episode number 2, I'll just once again give you a small introduction that why we decided to conduct this sort of a live discussion series. So, as most of you know, that we have been involved for the past 7 years in conducting training and skill development programs for civil structural engineers, and uh, we interact with a lot of structural engineers. We have a good fortune of interacting with a lot of you people, and what we get from that is that all the engineers that we interact with, they have a lot of passion, they have a lot of they're doing a lot of good work, but what they lack is sometimes uh, some mentorship and some hand holding from a fellow structural engineer. So through this online platform, or through this online series, we want to create a vibrant platform for the practicing civil structural engineers. So this concept is in the nascent stage and we expect it to evolve with time. What will happen in each episode? So those who have attended the episode 1, they know that we will have a few segments in this program. So every episode we will take up some problems. Those problems may be site related, analysis related, software or code related. So we will take up some common problems that we as structural engineers face. And then in the second segment, we will try to meet with some young structural engineer. We will try to learn from them, learn from their experiences. We will share ideas. So in our next segment, we would share ideas from you. So we month every time we float this episode online, we also have a Google form that we share. So in this Google form, we ask you to fill in some ideas. How do you think the work of structural engineers can be made better? So those ideas we would discuss, and then we will have open discussion. So it's not a very formal type of a setting. It will be a impromptu discussion and a casual discussion that we would have through this episode or through this series. So that is what we have planned, and we move to the first segment. So as you know, in the first segment we will take up some problems that are commonly faced by practicing engineers and their possible solutions. So in this episode again, does someone remember last time which problems we had discussed? So last time, if you remember, we had discussed two problems. The first problem was, I think, of the uh, concealed beams. Yeah, concealed beam was one of the problems that we had discussed. And the other problem that we had discussed last time was, I'm also forgetting. Does someone remember? So we had taken up two problems. I'm forgetting the second problem that we had taken, hidden beam. Yeah, hidden beam was one of them. Concealed beam or hidden beam was one of them. The second problem I'm unable to recall, but those two problems were very, I would say, what to say, they were quite relevant for the structural engineers, isn't it? So this time also we have taken two problems that we think are commonly faced by structural engineers. So first very important problem that we will be taking up this episode would be how to define the proper and correct parameters in StatPro steel design. So many of you are designing steel structures, and for designing steel structures, as you know, that we have to assign different parameters. There are a lot of parameters, around 15-20 design parameters we have to give when we are giving as per IS 800 2007. So a correct understanding, proper understanding of these codal parameters is very necessary. But most of us have some confusions, and I have seen many practicing structural engineers, many senior engineers facing difficulties in that. So this is the first parameter. So in this episode, the first problem we would like to take up would be the design parameters assignment in StatPro. Yes, so as the audience is telling me that the last time the first problem we had taken was of the correct of the sway, non-sway, and the ductile columns in E-tabs. Correct. Thank you. So this time we have taken two different problems. The first problem, as I just explained, would be the parameter assignment in StatPro, and second very important problem that we face is how to assign the pier labels in RCC structural walls. So many of you have this doubt and you have raised these issues on various platforms. So we would like to address these two issues. So as I told you, so let us start with the first problem: how to correctly understand and assign these steel design parameters in StatPro. So these parameters, what are parameters? They are basically the codal values or the codal methods or some inputs that you need to give for correct design. So giving them correctly and appropriately is very important. So do we know it? And if we do not know it, let us look into this issue. So there are various parameters. I'm going to take them one by one and we'll quickly go through them. So when you want to design any steel structure, before you start the design, you have to give these parameters, and I think you know where these parameters are there in the stat. I hope the audience is aware. So there is an option to define parameters, design parameters. So one by one, I'll just go through them quickly, and at every location, I have tried to give the correct codal provision for it. So the first parameter is alpha. What is alpha? So alpha factor is used by the StatPro to calculate the rupture strength. So this alpha uh, is used in the preliminary formula for rupture strength calculation. Okay, and the value of alpha stat takes as a default this value equal to zero point 0.8. Now what is the problem? Unless we do not do the connection design, this alpha value is not known. So therefore stat takes a preliminary value of 0 0.8. Okay, so this is the first parameter. What you should do when you are starting with the member design, since we are not sure of the connection, you can have this alpha of 0 0.8 to begin with. Okay, so the default value, as I told, is 0 0.8. You need not do anything with this value. You can keep it as it is. The next parameters are ATG, ATN, AVG, and AVN. Does anyone know what these parameters stand for? So the next four parameters, yes, is anyone aware? So the next four parameters are for the calculation of block shear. So as per this code, as per the present IS 800 2007, for the first time, block shear check has been introduced. So these four areas actually depend on the connection geometry and on the connection configuration. But because STAT does not do the connection design, we have to input these areas ourselves. Okay, so ATN and ATG are the net and the gross areas for tension. AVG and AVN are the gross and net areas for shear. So unless you do not give these values, STAT will not perform the block shear check for you. So this is important check when it comes to tension members. So these area values have to be given by the user if they want that STAT should perform the block shear check. In addition to this, you also have to give this DBS parameter designed for block shear. So you have to give this parameter and you have to give the four areas to ensure STAT does the steel design. The next set of parameters are the beam parameter. So this is simple. This actually gives you the locations where STAT will be performing the design of elements. So as a default, STAT will perform the design at 12 locations at every 1/12th of the member length. So the design value is every 1/12th, and you can keep it as it is. The next parameter is this CAN parameter, or the beam type. So three options are given to you: general, cantilever, simply supported. Is anyone aware where these values are used? Where is this beam type used in the steel design? Hello. So in case your beam is laterally supported, so for the laterally supported moment carrying capacity calculation, you have to use these values. When your beam, you are calculating the moment carrying capacity of your beam about the minor axis. So about the minor axis in steel, we consider our beams as laterally supported. So in that case also, this parameter is uh, this becomes important. Okay. So as a default, STAT takes it a general beam. Then the next three parameters, CMX, CMY, and CMZ. Where are they used as per the code? Yes, tell me, where are these values used? So these values are used, if you know, these are used when you want to design the member for combined bending and compression. So when you want to design your member for combined effects, then these values are to be used. So CMX is actually called as CMLT in STAT. STAT calls it as the CMLT. So table number 18 of IS 800 2007 gives you these values. As a default, STAT takes it as 0.9. This value is on the conservative side that STAT takes. ETABS, if you do the steel design by ETABS, how many of you do the steel design using ETABS? Okay, so if you have ever tried to do the steel design using ETABS, you will see that ETABS calculates the CMX, CMY, and CMZ values on the basis of bending moment diagram. So ETABS is able to calculate it in a better way. STAT is unable to do so, and therefore it takes the value as 0.9. And remember, it is a conservative approach that STAT adopts. The next set of parameters are for the deflection check. Generally, we do not use the deflection check so much in STAT because it is quite a cumbersome process. So three parameters. One is the DFF. Here you can give the span upon allowable deflection ratio. So you get these values from table number 6. So if you have gone through table number 6 of IS 800, you will see that they have the allowable span to uh, deflection ratios given, isn't it? So the DFF has to be input, and then to tell STAT that which is the starting point and which is the ending point of the beam, you have to give these dj1 dj2 values. So this is quite a cumbersome process because for every beam you have to give these dj1 dj2s, and therefore generally we do not like to use it. Okay. Then the next set of parameters that we give are not usually used. So these are the maximum and minimum depth for design, not used generally. uh, and I have personally never used them to assign to any member in the design, so I'll skip it. Then the next set of parameters are for FU and FY. So these give you the grades. The ultimate stress is given by FU, and the yield stress is given by FY. So I think all of you know that as a default, STAT takes the steel as mild steel. So STAT will take the FU equal to 410. It should take it equal to 410, though it takes it equal to 420, and the yield stress would be 250. What are the other steel grades that you have other than mild steel? Yes, anyone has used any other steel grade in their projects other than mild steel Fe250? Have you used any other steel grade? So other steel grades, so those who do PEB designs, they might be using the 350 grade, isn't it? They might be using the 350 grade. I think you have used it. So PEB people, it's a very common thing to use the 350 grade. Those who used cold form designs, they use the 550, 400, and so on. So very high strength grades they use. Yeah, a lot of hollow sections come in the 3110 grade. Correct. So there are a lot of other grades that are also available. So Rahul is saying that 3110 for hollow sections. Praful is giving the grade as per the AISC. So a lot of other grades also. So through this option, you can give the grades. Now some very important uh, parameters. So you must have seen these parameters KY and LY. Where are these parameters used? So these parameters are used for calculating the effective length about the YY axis. Okay, about the local axis YY, you have to give either KY or LY, and these values will be used to calculate the effective length of your member. Now remember that these KY or LY that you give, they include both the effects of framing conditions and sway effects. So it's a combined thing in STAT, that through one factor you can account for the framing condition as well as the sway effects. And about the YY axis, you can either give KY or LY. These are used for compression capacity calculations, and it happens through clause 7.1.2.1. Very important. So either you give KY or you give LY. Similarly, the next set of parameters for effective length about ZZ axis, that is KZ and LZ. The next set of parameters is KX and LX. Where do we use them? So these are used for calculating the lateral torsional buckling length, LLT. So if you remember, as per the code, it is the LLT. This LLT is then used for calculating the MCR value for the unsupported beams, laterally unsupported beams. So either you give KX or you give LX, whatever you feel like. The next set of parameters is the lat condition. I saw a very senior person telling this lat as the laterally supported for seismic loads. So remember, this has nothing to do with seismic loads or gravity loads. Okay, this purely depends on the uh, lateral torsional buckling effect for your beam. So if your beam is laterally supported, then you give this lat parameter. If it is unsupported, you leave it as it is. Very important parameter. When do we call our beam as laterally supported? So when the compression flange is completely restrained, then we call it as laterally supported. If you are using hollow sections, then also we can call them laterally supported. Very important parameter, but not usually required, because our general beams are laterally unsupported beams. Then another important parameter is the LST parameter. So this is not directly used in design anywhere, but rather it is used for the serviceability requirements of plate girders. The next parameter, lot of parameters you see, and it has to be understood in a very proper manner. So the next parameter is the main. So if you are doing steel design, you have to follow certain slenderness ratio criteria. So as per table 3, these values have to be followed. Then this Nsf factor, that is the net section factor. Net section factor. Where is it used? So it is used for calculating the net area. Where is net area used? Net area is used for calculating the rupture strength. So as a default, stat takes Nsf factor equal to 1. That means it will consider the gross cross-sectional area equal to the net section area. So if you do not give any NSF value, STAD will calculate the gross cross-sectional area. STAD will calculate the rupture values, rupture strength using the gross cross-sectional areas. So you have to be careful. This again depends on the uh, connection type. This profile not very important. If you are using certain specific profiles in your design, then it may be important. Then this psi value, so this is used for members which are subjected to combined tension and bending. Okay, so this value is given in clause 9.3.2.1. Then this ratio, not again very important. So this is a limit which you can set. This is a ratio of the permissible stress upon this is a ratio of actual stress upon the permissible stress, not important. Then extremely important, so very very important parameter, that is the STP parameter. So I have seen many people, they do not know about this. So whenever you are using any built up member, or you are using any welded member, or you are using any member that is not hot rolled, then you have to give this parameter as the welded section parameter. Very extremely important, because this leads to almost a 10 to 15% of over calculation. So you have to give this parameter, and you have to give it as welded. If you are using any built up section or any hot rolled section, any built up section, any welded section, any section that is not hot rolled, you have to give this parameter. How this parameter is important, where it is used in the calculations. So when you have to decide the buckling class as per table 10 over there, and when you want to calculate the imperfection factor uh, for clause 8.2.2, so those are to be used over there. T main not that important. This is the slenderness ratio limit, not that important. Track is again very helpful. If you give the track 2 command, it will give you the maximum output at the maximum level of details. So it's a good, I would say, practice to give track 2 and then you would be able to see the detailed design. Very helpful. Then these last two parameters, TSP, TST, where are they used? So when you have to calculate the shear capacity, especially in plate sections, and if the dy TW exceeds 67, then you need to assign certain transverse stiffeners. And if you have assigned transverse stiffeners, it helps you to enhance the shear capacity of your web. So these two parameters are used over there. Again, very important if you are using plate sections. So these were the few parameters that I wanted to discuss. I hope you have been using the appropriate and correct parameter for the steel design. Any questions or any comments on this? Okay. So we'll quickly go to the next problem, again, which is quite common, and it's very, uh, I would say, very commonly faced by the structural engineers. So what you see in the plan right now, what you see in the image is, these are plans of your RCC walls. So I have shown you two cases. What do you see? So these are multi-legged RCC wall. Now what is the correct way to, or which is the correct approach to assign the pier labels? So what do you see in both the cases? The first image, what it is giving you, so it there we have assigned three different pier labels, isn't it? And on the image on the right, you will see that we have assigned same pier label to all the legs. So according to you, which is the correct way? Yes, tell me, which is the correct way to assign pier labels? This is quite important because many of the engineers ask us this question. when we have to assign pier labels in ETABS, if we want to design RCC structural wall, what we call as RCC shear walls, we need to assign the pier labels. So which is the correct way? Should we assign same pier label to all the legs, or should we assign different pier labels? So that is what we would like to. No, so case 1, case 2 are both two different cases, and these are both are cases of multi-legged RCC walls. So separate label or same label. So Nagesh is saying separate labels, and Vega is also saying separate labels. So this is very important. We need to understand it clearly, because this is a common problem that structural engineers face. So what is a pier label? Basically, pier label, as Mega is saying, it integrates the forces and moments over the leg. So wherever you give a same pier label, it will integrate the forces, moments, and the section properties are also accordingly taken. So when you have to calculate the moment capacities of legs, you need the section properties, and the section properties are then taken as per the pier label assignment. Also, when you want to calculate the moment carrying capacity for the PM interaction, then also the section properties are taken from the pier labels. So in cases where different legs of RCC walls are expected to have different axial loads, it is better to assign different or separate pier labels to the RCC wall. So if you see what we have done, this is a plan of a hotel building, commercial building. On the left side, the plan is symmetric about the y-axis. So on the left side, if you see, we have assigned same pier labels to the three legs. Is it visible? And for the wall on the right side, we have assigned different pier labels. Okay. So which one is more accurate? We would like to see that. Now you will appreciate that in this case, for example, this RCC wall has three legs. The wall that you see on the left, it has three legs. All those legs will be subjected to quite different axial loads. So it will be inaccurate to assign same pier labels to them. We will see it. You can see this close-up view of the two walls. On your left is the RCC shear structural RCC wall on the left hand of the plan. So we have assigned same pier labels, and on your right you can see we have assigned different pier labels to the legs, separate pier labels. And when we run our analysis, you can see the results. So the wall where we had assigned same pier label, it is giving us a 1.24 percentage of steel longitudinal reinforcement. And when we assign different pier labels, you can see each leg is giving us different reinforcement. Can you see this? So the separate pier label assignment is more accurate, because each leg of your RCC wall is actually subjected to different loads, different movements. So the capacities also should be calculated differently. So same pier label assignment should be avoided. Okay. So this was another issue that we wanted to address. So in this episode, these were the two problems that we wanted to address. If there are any queries or questions you want to ask about these two problems that we have taken, we can listen it from you, or else we can move to our next segment. So I hope these two things are understood. What did we try to discuss this episode? First problem was how to correctly assign the parameters in STAD, and second problem that we tried to discuss was uh, what to do about the peer level assignment. Okay, so separate peer levels is what you have to do. Very important. Whenever you have a RCC structural wall, always assign separate peer levels to the individual legs. Good. So this was about the problems that we wanted to discuss in this episode. So now we move to the next segment, and that would be the experience sharing segment. Okay. So in this segment, we we always try to invite uh, practicing structural engineers, young structural engineers from across India, you could say. Okay. So this time we have invited a very young structural engineer, engineer Shivani Soman. So she is young, but she comes from one of the most ancient and continuously inhabited cities of the world, Ujjain, and she is founder and director of a consultancy firm that she has started, Soman Engineering Services, and their company is involved in the projects across India, and they specialize in RCC and steel commercial as well as residential structures. So she is going to be uh, our guest for today. So I welcome her, and we would like to listen from her experiences. So just give me a minute, and I will invite her to the episode. Yes. So hello and good evening.
Good evening, sir.
Is my
Good
voice properly
evening.
audible? Yes. Good
Yes,
evening.
sir.
Hello.
Sir, is my voice audible?
Yeah, yeah. Talk a little bit louder.
Okay, sir.
So hello
Uh,
and welcome, and
Thank you,
thank
sir.
you
Thank
for
you for having me here today. Thank you so much, sir.
yes, thank you for taking out time and joining us on this episode today. So Shivani, if you could tell our audience a little bit about yourself and what you have done till now in
Okay, sir.
in
So,
brief.
sir,
Yeah.
currently I'm working as a practicing structural consultant for last 5 years now, since 2018. And after completing my MTech in structural engineering, I worked for almost 2 years uh, in Indore only. And then as a structural engineer. Hello, sir, is my voice
Yeah,
audible?
yeah. Your voice is properly audible. Yes.
So, sir, after working for 2 years, I resigned from my job, and since then I'm working as a full-time consultant.
Okay.
And sir, currently we are working in residential and commercial projects mainly. We
Okay.
have
So
also done some culvert designing projects and but mainly we are focusing on residential projects like for now.
okay. So how did you decide to start as a structural engineer, as a consultant, that is, because many few people like you start as a I mean, you have opened a consultancy firm of your own, isn't it? So how did you
Yes.
decide to do that?
So, while doing my MTech, I have thought of deciding like doing something like that. But sir, I had like no idea on how to execute it because sir, like I remember when I passed out and I went to search a job. As in previous session also, I think Sandeep sir was there. He also said
Uh,
that he had a problem in that execution part because in college what they teach us is not applicable exactly on the field sometimes. So sir,
yeah.
after like working for almost 2 years, I also took some private projects in Indore,
Okay.
Ujjain and nearby local areas. So,
Okay.
sir, after that, it was really fun to, execute an entire project by myself because, sir, like in job, we are just focused on a single part of a project. We are never a part of an entire project.
Yeah.
Like when I was working as a structural engineer, I used to basically initially I used to just model structures on STAD and all. That
Uh,
was the only part given, but when you execute a work all by yourself, then you get to know all the stages that are there. So it was really exciting, and still I'm learning because each project is has a different kind of challenge in it. So, sir, but it was fun. Some initial paperwork, sir, I will say initially we do not need that much of paperwork, like for small,
Yeah, I wanted
like
to actually ask that because if, let us say, we want to start a consultancy firm of our own, how to go about it? मतलब कितना paperwork या कुछ certification या what do you have to do if you want to start a firm of your own?
So
Are there any
initially, what
permissions?
I did was there was no as such paperwork. I mean, the paperwork is not compulsory,
अच्छा,
but we can have some sort of municipal that we have the municipal corporations like in Ujjain and Indore we have Nagar Nigams. So, sir, we can take some sort of license from there. They have like a civil engineer's license, structural engineer's license. So, we can take that, but that is not like mandatory to start it. But it is good to have something as a means that will get an additional benefit if you want. But so that only I did, and that's it, sir. And some basic website of your own you should have. And but sir, apart from that, what I mean, what I experienced is that the word of mouth is important. I mean, the more people know what you're doing, the more work you'll get. Uh,
yeah. Yes. So there is no minimum experience criteria required to start a consultancy?
So I worked for just 2 years, and
अच्छा,
but sir, I think we should know the entire project flow at least, or
yeah,
some parts of like how the project is going to flow, how you are going to get a project, and then how you are going to execute it, and I mean from starting till the end, and also the side problems that you are going to get. So, sir,
right,
basic that knowledge you should have. So,
correct. So in all these years, when I mean, uh, as a director of your consultancy, which are some of the challenging projects you have done till now, and
sir,
what were your learnings from them? Any project you would
so,
like to tell us?
so we have done mostly residential projects. Some commercial projects also have done. But sir, what I faced, I'll discuss a residential project today.
Huh.
So, sir, the first thing that was the drawings. Like, sir, this is in the initial stage. When we used to work as a consultant in an office, established office, they have bigger projects. So, sir, our drawing is going to go to a site which is having a experienced site engineer and experienced labor contractor also. But, sir, here when we were initially, the labor contractor is not a literate person. So,
Yeah,
sir, what I faced the difficulty was that they are not able to understand the drawings presented by us, because
correct.
they are looking at the photographs and they know some numbers. They are not. I mean, that difficulty that we should make our drawing as simple as possible for a small scale. This is I'm talking, because
Yeah,
the labor contractor has no idea. I mean, he cannot read your drawing.
yeah,
And so there is no one to like there is no site engineer above him, like for small scale projects. So I
yeah.
think, sir, that was the problem.
Huh.
That the drawing for such projects should be very simple.
Huh. Correct.
And sir, one more problem nahi, one more I can say, the mistake that they are making is
Huh.
that's in that plinth slab design.
Yeah.
We give floating slabs.
Yes.
But sir, on the field, basically in residential projects, they are just making it as a continuous slab. And
Correct.
even we tell them that this is a floating slab, so the reinforcement should not come on the beams, on the
Yeah.
plinth beams.
Yeah.
And I even asked this doubt to you that day also, that
Ah,
because that is going to create cracks in your walls.
correct.
So, so that is one thing that I
They
mean
do
the
not listen to it.
local engineers are not doing, and they are not even concerned about that.
Yeah. And as engineers, we are not taking the load of clean slab on our structure also, isn't it?
Yes, sir, that's and that is creating the cracks in the walls.
Yeah,
I
that
mean
is
that
another
will
reason.
create that. So, sir, that was one problem that I faced, and one more issue was what's that about eccentric footings.
Ah,
So basically, in any residential projects, we have fixed property lines.
yeah.
So we are not allowed to extend our footing. I
Yes.
mean, uske, I mean, we cannot
हाँ,
extend it
उसके
beyond
बाहर
that
नहीं ले
line.
जा सकते हैं। प्रॉपर्टी लाइन के बाहर नहीं ले जा सकते हैं फुटिंग।
So, sir, uh, now if we give like a tie beam or something to tie each and every footing, that is going to add up to the cost.
और प्रोजेक्ट
So,
आपके हाथ से चले जाएगा।
so sir, that is one problem. So, what I do, I mean, I don't know that is correct or not, but at least we should tie the columns at plinth level in both directions by plinth beams. So
हाँ,
that may help in that eccentric I mean, action because even if we have thought of digging a pit and making connecting two footings together, but
yeah,
that becomes too costly. Sir.
yeah.
So usually no one agrees to do that. So so, sir, these are some of the things that I don't know this is correct or not. So, what do you think, sir? Because they just simply don't agree to like connect it under the ground.
Yeah, so
So,
they will not, it does not help actually, it helps, but it does not help if you put a beam at the plinth level, क्योंकि that is like बीरबल की खिचड़ी, it is so far away from your footing pressure distribution zone
yes, sir, it is almost like the
that
footing is 2.5 to 3 meters deep.
yeah. So
So,
it does not help you per se, but then you do not have any choice. Why you do not have any choice? क्योंकि फिर आपका प्रोजेक्ट आपके हाथ से चला जाएगा अगर आप टाई बीम्स देंगे फुटिंग में। So
yes,
I also feel that residential projects are sometimes more difficult than your commercial or even a multi-storied projects, isn't it? क्योंकि एक तो
yes, sir.
you will be faced with eccentric footings, you will be faced with columns that are having higher reinforcement percentages, you will be having moments about the minor axis in columns, क्योंकि generally that is how
Yes.
we
Yes, sir,
position
and
our
they restrict the column size to 200 mm.
200.
Every
Yeah,
residential building, they will
yeah,
restrict it to that size. So we cannot exceed that as well.
yeah. So actually speaking, residential projects are more difficult than the general commercial or residential.
Commercial project. Yes, sir,
General
because
commercial
commercial projects
projects.
are very standardized. You
Yeah,
get a single, like similar base throughout I mean, the building or anything. What even if in a hospital building we get similar kind of the frames we get, but
yeah,
not in residential buildings. Sir. That
right.
is very difficult. I mean, each project is, and also the economic aspect is there. That
हाँ,
that is also not should not exceed. I mean,
16 के सरिये डालने देते हैं आपको? ठीक है, गुड
so
गुड।
sometimes even उनको ऐसे लगता है कि 10 mm bars are
हाँ,
sufficient.
सफिशिएंट,
फिर
या,
उससे भी ज्यादा होना है, मतलब 16 तो नहीं, कभी भी नहीं.
हाँ, गुड, इंटरेस्टिंग। So, anything else you want to tell us? How, what are your, what is the vision you have for your consultancy in coming years?
So vision, I have thought of doing as many projects as I can, because sir, only doing more work you will get more work.
Yeah,
I mean, so we cannot have that job like when we are
mental.
in job, we have a different mindset that we are going to get paid after every month. But in consultancy, you cannot think that. Like at least for initial 5 years, we cannot think that. So
Yes.
I am trying to get as much work as I can,
Yeah.
and my vision is also that I have observed that in many consultancies, the speed of work is very slow. Even
Uh,
what I am doing also, the speed is very, I mean, we are not able to, I mean, we are not able to give the drawings at a faster rate, maybe due to that calculation part. And so, sir, I think the automation should be done as we have discussed in the previous session also,
uh,
that
yes.
some sort of automation should be there. So,
Should be
so my
there.
vision is to I mean, to get to work on a lot of projects, uh,
Yes.
and that's it.
Good. And any message for our audience? All the people who are attending are they are structural engineers. So any message you have for them?
So, sir, I'll tell. So that I think if you think of starting something of your own, or like your own consultancy or something, you should start it along with your job. Because sir, if we think that we will, after leaving our job, will start, that will be very difficult. So
Uh,
we, like most of us, have Saturday Sunday off, so
yeah.
we can take projects in that time. And I think we should do like number of projects should be higher than. I mean, we should not focus on the money part initially. We should
Yeah.
focus on doing more and more work.
Yeah.
That's it,
Good.
sir.
Thank you. Great to have you over here today. And
Thank you so much, sir.
if audience have anything to ask to Shivani, they can ask. She is in the stream right now, so if you have any questions, you may ask her. I think Mr. Tathagat had a question for you, that you were talking about tie beams. So tie beams are required at foundation level instead of plinth. So yeah, of course.
Yes,
So
sir.
I
They are required, but sir, the economy is the. I mean, they are required, but in smaller sites or on a small scale, people do not agree to do that, because
so I'll
if
just
we have.
yeah, I'll just clarify what Shivani was saying. She said that tie beams are required at the foundation level, but the clients, because of their, you could say, lack of knowledge, lack of awareness, they do not allow the tie beams to be provided at the footing level. So that was what she said. And then as a makeshift arrangement, instead of providing at the footing level because client does not allow you to provide, they provide it at the plinth level instead. That is a makeshift arrangement that they have, of course. But footings at the tie beam, sorry, tie beams are required at the footing level itself. That is what Shivani also said. Yes, very good. So if you have any questions to Shivani, you can ask. And she's on the stream right now. So during our open discussion also, you can ask her. So Shivani, right now I am just putting you out of the stream, but if there are any
Okay,
questions, I will call you back. Okay?
okay, sir.
Yeah.
Thank you,
So
sir.
just stay with us. Yes.
Yes, sir.
Okay. So we would like to thank Shivani for taking out time and interacting with us. So it is quite a different journey that she has had, and starting as a consultant and starting a consultancy of her own at such a young age is quite commendable. So if you have any questions that you want to direct to her, you can ask her during our open discussion that we will have. Okay. Now we move to our next segment, where we would like to take up some ideas. So I did not have enough ideas this episode, but still some of the ideas that we received from the Google Forms I will just like to put up over here. So uh, when we had called for ideas, we got a few mentions in the Google form. So engineer Sunil Kumawat, who is a good young upcoming contractor in Indore, he had put up this thought that when we are doing the geotechnical investigation, and if there is a basement that has to be constructed, then the level of water table should be mentioned. Yes, that is quite right. And this is a point right on the mark, because I have seen personally, we have seen projects failing and the basement slabs getting uh, just failing in serviceability criteria. Your basement slab cracking into two pieces, just for the reason that the water table was not properly considered for and accounted for in the design. So this is quite an important point that he has raised, and this is a good idea. You should, as a structural engineer, if you are doing any basement, always look for the water table from your geotechnical report, and more importantly, always look for the month in which the the month in which the geotechnical investigation has been carried out. Many times it happens that the investigation is carried out in the peak summer, in the peak Indian summer, and you know that the water table goes down during the summer seasons. So never trust on the summer season water table. So if possible, if it is not possible to carry out a geotechnical report during the post monsoon months, at least take into account a possibility of rise in the water table. Okay, so this was one of the ideas he had put, and very important that you should keep this thing in mind. Then the second idea, it's not an idea, it was just a thought. So engineer Punchto Dorji, he's from Bhutan. He says freshers need to gain knowledge by giving time. Yeah, so I would not say this is an idea, but of course, time is needed for anything and everything. So you have to devote considerable time for any sort of learning. Then engineer Rahul Brijpuria says, again, I don't think this is an idea, but he is saying by continuous learning and sharing experience with others, you Acha, this was an idea for the betterment of structural engineering profession. So he's saying how to become better. So by continuous learning and sharing experience, and one should not wait. जब आएगा तब देखेंगे अभी क्या करना है. So you should not have this attitude कि जब आएगा तब देखी जाएगी, and you should start right now. The right time is now. So that is what I think he wants to say. But this is again not an idea, not a very relevant idea as such. Anyway, so we did not have any good feedback, good comments coming from you this time. So I do not have a lot of ideas to share over here. Uh, so it is better that we can move to our next segment, and that is some open discussion that we would like to have. So if there are any questions, comments, difficulties, thoughts, queries, whatever you want to say, you can we can now interact. If you have any questions for our guest, engineer Shivani, you can ask those questions also. Okay. So Yogita ji had to say about Shivani that you are a very inspiring youngster. So
Thank you so much.
yeah. Then so yes, let us take some questions that we have, and let me just remove this. Yeah, and take up some questions. So Tathagat was asking regarding the peer level assignment. I believe he is asking if it is combined wall, one peer label will be more proper, or in that case also we should give peer labels separately and design. I do not understand what do you mean by combined wall. But as I told you, if there is a possibility that different legs of your wall may have different axial loads or may have different moments, then it is better to assign separate peer labels for it. It just makes much more sense to assign separate peer labels, because when you assign same peer label, the problem is that it integrates the axial loads, it integrates the moments, it even integrates the section properties. Integrate, by integrate I mean it will consider the entire multi-legged RCC wall as a whole. So that can create issues. So if you have separate legs, assign separate peer labels. Okay. Then Tathagat was saying, I think in response to what Shivani was saying, plain slab as in grade slab or conventional slab.
So, grades, can you sir clarify what is grade
Grade
slab
slab
or
means,
conventional?
so yeah, I'll just clarify. So what we provide is slab on grade. Grade means you have compacted
So,
column filling, and
okay.
on that you provide your slab. So when she was saying about plain slabs, the usual practice we follow is to provide slab on grade. Yes.
Yes, sir. So basically, we just provide a mesh of reinforcement. So that
Yeah.
slab is not going to behave as a continuous slab or what we provide in the roofs. So we
Yeah.
just provide a mesh to hold that concrete in place.
Correct. So it's a slab on grade and not a suspended slab. Yes. So then Kashyap is saying whether tie beams only for corners and edge columns of buildings are sufficient, or plinth beam is also required. No, so tie beams is required if you have a footing that is eccentric. Tie beam is only the possible solution. But if you are not able to provide tie beams, then you have to make certain makeshift arrangements. Okay. Then uh, depth of beam, yeah, anything. So ASAD is saying, okay, so he was telling about the uh, point raised by engineer Sunil Kumawat, and what he's saying. Yeah, so he is also lamenting on the poor quality of the geotechnical reports. No, so no. I would like to tell you over here that the geotechnical reports may also be good, but the problem is that they conduct the reports during the summer months, and then uh, they do not, I would say, analyze this, that they have conducted the geotechnical testing or water table calculations have been done during the peak summer. So that is a that is one analysis that we as engineers should also be able to do. See, geotechnical reports are also like the pathology reports that we get in the pathology labs, isn't it? So you do not make any judgment by just looking at the pathology report. Finally, it is the duty of the doctor to make the analysis and make inferences from it. So similarly, geotechnical report, you get the report as an engineer, you should be able to analyze it and should be able to get meaningful uh, outputs from it. Sachin, engineer Sachin is asking, please suggest any reference book for RCC haunch and bracket design. So I am not aware of any book. Maybe the audience can chip in with some suggestions. So I refer to Pillai Menon. I have told this in the earlier sessions also. We We feel that it is one of the best books available on RCC design. PC Varghese is another very good book, but I'm not sure about the other RCC books. The Miracle is saying, please take a session on explanation of soil report. Yes, this is good suggestion. In next episode, we will take up one report, and I'll try to tell you about the report, and we would try to analyze the report in the next session. Yes, so this is good suggestion. Then Tathagat is saying, please address my question given a bit earlier regarding combined wall. So his question, let me just go back. He had asked a question earlier. I'll just go back in the history. Yeah, I think I addressed it. If it is a combined wall, then it should act together. So I would say if there are two different legs of your combined wall, it is better to have different pier levels. Okay. Then Yogesh Thakur, engineer Yogesh Thakur was asking about the corbel design. Where is this question? IS can use to design corbels. I'm not sure about the question over here. Yes, Yogita ji is saying in response to the question about RCC haunch and bracket design. So Yogita ji is suggesting that you should refer to Shah Karve. It's a big book, but very useful in bracket design. Good, thank you. Then Praful Soni is saying in underground tank with different level, multi-compartment tank raft slab designed as whole or in part. Yes, good. So if your underground tank has different they have different bottom levels, then because there is a level difference, you will have to design those rafts separately. Okay, so they should be designed as separate entities because there is no continuity that you are getting as they are at different levels. So you will have to uh, design them separately. What is the effect in connect when they are okay? So he's asking when these rafts or when these bottom slabs are at different levels, what is the effect they have on the walls? So I cannot explain that effect to you right now. uh, I mean, it has to be done by some sort of modeling. That is what you have to do. Otherwise, there can be so many possibilities that to explain it to you by some manual method is not possible. Then engineer Ishwar Singh, he is joining from Nepal. He's saying throw some light on steel secondary beam and the primary beam arrangement on floors. What would be the spacing and commonly used size for secondary beam up to 3-4 story steel building? So generally, secondary steel beams will usually be required to support your flooring system. So in your steel structures, you can have the commonly used flooring systems can be either it can be a RCC deck slab, or you can have gratings, or you can have checkered plates. So depending on what flooring system you are adopting, you will generally have to plan the secondary beams. So it does not depend on the story. I mean, it does not depend whether your building is 3 story or 4 story. It would rather depend on how much load is expected on your floor and what flooring system you have adopted. So that will decide, or that will dictate what secondary beams you are providing. Then Kashaf is saying cantilever slabs for porches. Okay, so we will take this issue in some of the upcoming episode. Yes. Then Mega is asking if tie beams are not given at footing level, then the depth of beam is increased at plinth level slightly. No. So the tie beam not being given at footing level will have no implication on the depth of plinth beam. So the answer is no. Then uh, Tathagat is saying in separate peer levels, if we give and take the design accord, if we give and take, but in construction, the individual leg steel will anchor inside adjacent wall legs due to certain movements will transfer. So Tathagat is saying that if we design the peer levels, sorry, if we design the different legs separately, and if we are going to anchor the reinforcement of one leg inside the other leg, but remember the anchoring would happen mainly for the horizontal steel. And right now, what we are talking about is the vertical reinforcement, isn't it? So it does not matter much. It does not matter much, even if some of the horizontal steel is anchored inside the other leg, it won't have so much of a issue, because mainly we are talking about the longitudinal or the vertical steel over here. That is the steel of importance when it comes to RCC structural walls, isn't it? And then he is continuing the question by asking how to get the holistic approach for this movement transfer. So, as I told you, bars being anchored, usually nobody anchors the horizontal bar so much in the other leg. And as such, if you see, those bars are there to take the shear, they are not taking any kind of movement. So, in your RCC structural walls, the main bars are the vertical bars which take the in plane movement, isn't it? So those are more important than your horizontal bars. Horizontal bars are for shear. Yeah, so Akanksha is answering to Miracle. Yeah, so we had conducted a course in the past, and that is actually still there as self-paced course, where we had taken up analysis and understanding of lot of reports. Then Rahul is saying raft of underground tank is designed as conventional slab. So it depends how you want to design. If you have an underground tank and if you have walls all around, then one way can be to design it as a conventional slab, provided that your shape is regular. But that will be slightly conservative, because in that case you are not actually taking the moments that will be transferred from wall to slab. So that effect you are actually missing out on. So yeah, it is a way to design the raft of the underground tank, but it is slightly conservative, I would say. Okay, good. So anything else? So I think that's all that we have, and thank you all for joining. That too on a weekend. I mean, start of the weekend. So thank you for taking out time and joining. And we would also like to thank Shivani for joining us today. So thank you so
Thank
much
you,
for
sir.
joining. Yeah,
Thank you, sir. Thank you so much.
thank you. So that is all we have for today. Bye bye. Have a good weekend. Have a good coming days. So coming days are going to be full of festivals. So have a good time during those festivals, and then we will meet you later during the month. Okay. So next episode probably we will have in the fourth week of August. So that is all we have for today. Thank you. Bye bye and good night. Take care. Let me just put up a banner of thank you. Yeah.